Hello friends, myself Durgesh Chouk. Today we the group of three, Durgesh Chouk, along with me, there is Tushar Bhosale and Chetan Patil. Today we are going to cover the topic Apriori algorithm. So we will see some theory concept as well as we will cover the code and understand how Apriori algorithm is run. So firstly, what we will see what is Apriori algorithm. So the Apriori algorithm is a popular method used in machine learning, especially in the field of association rule learning. It is widely applied to identify frequent item sets and generate association rules from transaction data. This technique is commonly employed in market basket analysis. So, recommendation systems and other domains where the relationship between variables or items need to be uncovered. So we will see some key concepts in a prior algorithm. So the first concept is the frequent item sets. Item sets stand for group of items that frequently appear together in a data set. So the next concept is support. So how we will see how support is calculated. So it is calculated as the proportion of transactions that contain a specific item. So the formula for this same is, so support A is equal to number of transactions containing A which is divided by total number of transactions. The next concept in a priori algorithm is confidence. So a confidence is a measure of the likelihood that an item B is purchased with item A is purchased. So for the same formula is confidence A related to R, which is equal to support of A union B divided by support of A. So the last concept of a priori algorithm is lift, which indicates how much more likely item B is purchased when item A is purchased compared to random chance. So lift A to B is equal to confidence A to B divided by support of B. So now we will discuss some steps of the prior algorithm. So the first step is generate frequent item sets. The next step is to tune candidate item sets. The third step is generate association rules. And the last step is the example of generate association rules, which are from the item set A, B, C. Possible rules include A to B, B to C, etc. Now we will see some advantages of a prior algorithm. So here are some advantages of a prior algorithm. Efficient for large data sets as it avoids computing support for non-promising item sets. The next advantage of a prior algorithm is easy to implement and interpret. It is the easiest algorithm in machine learning. So there are few disadvantages also of a priori algorithm. So one of these is computational cost can grow with the size of dataset and the number of unique items. The next disadvantage is requires multiple passes through the data, which can be expensive for massive dataset. Here are some real-time applications in which a prior algorithm is used. So one of these application is market basket analysis. The next one is recommendation systems, healthcare, and web usage mining. In web usage mining, it is used for analyzing browsing patterns.
Hi friends, today I will show you how to implement the Apriori algorithm to discover interesting association or rules in transaction data. We will use Python and the Apriori library, so stick around to see how it works. So here is our code. First, we need to install the Apriori library. This is the library that helps us apply the Apriori algorithm. First, run this code. Second, here I am importing two libraries. First is pandas to handle our data. Second is a priori for the a priori algorithm. Then load our dataset. The dataset contains transaction data where each row represent a transaction and the columns the contains the purchased items. Let's process this data. Now, the a priori algorithm needs the data the form of a list of transaction. We convert our data frame into a list. The code is here. Then next we apply the a priori algorithm using this line. Let me break it down. So mean support is equals to 0.0045. This sets the minimum support threshold. Next, minimum confidence is equals to zero point 0.2. This means minimum confidence for a rule to be considered. Next, mean lift is equals to 3. It means minimum lift value which measures the strength of a rule. Then mean length is equals to 2. Only look for rules with at least two items. Next, the result are stored in association rule. To make it easier to analyze, we convert into a list. Then we can print the number of rules found. Using this line, this gives us count of all the association rule. Thank you.
Hello everyone, I'm Tushar Bhosale, roll number 64. I will cover how to display frequent items from dataset and explore the first 10 rules generated by the Apriori algorithm. Let's get started. Let's start by displaying the frequent items in the datasets. First, we initialize an empty set called frequent items. We use set because it automatically handles duplicates, ensuring we only store unique frequent items. Next, we loop through each association rule in association result. Each rule contains frequent item sets and other matrix where we going to extract items from these sets. Within each rules, we access the item attribute. These contain the item that appear together in rules item set. We loop through each pair of items. For each item pair, we add it to frequent items set. Since we are using a set, duplicate are automatically avoided. Ensure only unique frequent items pair are stored. Now we print the frequent item. This tells us each item or pair together frequently in database. Database on minimum support threshold we set earlier. To make output more readable, we print a separate line. This helps in distinguishing between the different part of output clearly. Now let's focus on displaying the first 10 rules generated by Apriori algorithm. Here we loop through the first 10 rules in association result. We use enumerate to get both index and item in each iteration. This helps us limit the output to only first 10 rules. For each rule, we access the items attribute again to get item set involved in the rule. We store this in variable pair. Next, we convert the pair, which is a set, into a list called items. This makes it easier to work with and print as list maintain the order of items. We then print the rule itself. The first item in the list is base item and the second item is the added item. For example, if a rule is milk bread, it means that someone buy milk, they like to also buy bread. Let's now extract some important metrics for each rule: support, confidence, and fit. We print support of rule. Support tell us how often an item set appear in transition. A higher support value means the item set is more frequent in dataset. Each rule has a list of ordered statistics that contain the calculated metrics like the confidence and left. We loop through series through these statistics for each rule. We print the confidence which tell us likelihood that consist adding items appear when the base item is already present. A higher confidence indicate a strong rule. Finally, we print the lift which indicate the strength of the rule eh, relative to random chance. A lift value greater than 1 suggests that the items are positively correlated. To keep the output clean and well organized, we print the separator line after displaying each rule. This makes it easier to differentiate between the rules. Here an example output generated by Apriori algorithm. The number of rules 822 association rule generated from the dataset. These are the possible relationship between the item based on the transition data. The algorithm also identifies set of frequent items such as apples, Coke, avocado, and many more. These are the items that appear together often in database. Let's take a rule. If someone buys the apple, they are likely buy the beef. As well, the rule has following matrices. The support means that the rule applies in about 1.4% of the transition in dataset. In confidence of 82.35 tell us that when the apples are purchased, there are an 82.35 chances on beef will be also be bought. Lift. Lift value is 3.63 indicate that this rule has higher likelihood of occurring than the items we bought randomly. And that's quick overview of the how Apriori algorithm works and how we interpret the output. We displayed the frequent items, explained rules, and explore key matrices like support, confidence, and lift. Thank you.